All right, welcome back, everybody. It's good to be back. Good to be in the classroom again. Good to be teaching to actual people and not just making videos. But again, so what I was talking about here is the kind of like the second part of what we were learning within the choice board was all about how to solve quadratics. Okay, we talked about how when we graph quadratics, the intersections of the x-axis, those are the zeros of the function, the roots of the parabola, the roots of the equation, whatever you're going to call them, those are all synonyms. But basically, those are the x-intercepts, right? To solve a quadratic, you're solving for the x-intercept. Now, are all quadratics factorable, right? Like if I said this, x squared plus 3x plus 5, and I said, okay, let's find the x-intercepts of that. What are the factors of 5 that add to get to 3? Nothing, right? Because it could be either 1 times 5 or negative 1 times negative 5, and that's it, right? And none of those add together to get 3. So how do we solve things like this? Well, that's really what's going to take us through sections 5.4, 5.5, 5.6, right? That's really what we're going to work through now. How do we solve equations that are not easily factorable? Because our easiest route to take is factoring. That's the easiest route to take. Okay. So what happens if we cannot factor? What happens? How do we solve for the zeros? How do we find the x-intercept? How do we find the roots of the equation when it's not factorable? All right. So our first method is called completing the square. Many quadratic equations contain expressions that cannot easily be factorable. Right? We talked about that. For equations containing these types of expressions, you sometimes can use square roots. So if I really would like, if it's possible, it would be great to try to solve this, directly for x. What do I mean when I say solve directly for x? Well, do you see how there's no b term? Like, do you see how there's no 3x term, right? There's just the x squared and the number. When there's no b term, when there's no just x term, what you can do is just solve directly, which basically means that I just add the 12 over to the other side. So x squared is equal to positive 12. And then I square root 12, right? What undoes x squared? Well, square rooting it, right? So therefore, I would have x is equal to the square root of 12. And notice that I leave room a little bit. Okay? I leave room a little. Oh, I said 20. I'm going to write that. That's weird. I don't know why it says 20 and you're guided down to 12 on my on my board. That's weird. But at any rate, you would do the same thing. Like if I had x squared minus 20 equals 0, you would say x squared is equal to 20, add the 20 over to the other side, and then we would square root 20. Now, the whole thing here is, though, I have two different solutions. Remember, we talked about how we cross at two different locations. When you have something like this, you need to remember to put a plus or minus in the front of it. Why? Well, because x could be either the positive or the negative version of that number. Okay? It could be either the positive version or it could be the negative version. Right? Like if I had this, x squared minus 4 equals 0, and I said, what numbers could I plug in for x to make that true? You could say 2 or negative 2, because if I square negative 2, I get positive 4. 4 minus 4 is 0. So there are two different solutions, either the positive or the negative version of that number. Now, don't forget, we have to reduce down our square roots. Okay, you have to reduce down your square roots. We talked about this at the beginning of the year, and this kind of hung some people up. Remember, this is like if I say 2 times 10, 2 times 5, buddy up the 2's. So plus or minus 2 radical 5. Or if I wanted to do 12 here, 2 and 6, 2 and 3, buddy up the 2's, 2 radical 3. Right? I also introduced a way to remember it where you said, okay, what's the biggest perfect square factor that I can divide out of 20 or divide out of 12? Well, in this case, they're both 4, right? That's the biggest perfect square that you can divide out. So 20 divided by 4 is 5. So I pull out the 4, I square root the 4, I get 2 on the outside. That's where I get the 2. And then the square root of 5 on the inside. Okay, so this says that to solve a quadratic equation, you can take the square root of both sides. Be sure to consider both positive and negative square roots. Again, This is if there's no b term. We can only do this when there is no b term, when there is no x squared plus 3x. You know, that plus 3x. So just the x term, the b term. Okay? Okay, let's take a look here. 4x squared plus 11 is equal to 59. Why is this different? That's so weird. Okay. I'll make my screen match yours. I don't know why that's a 2 instead of a 4. Whatever. Doesn't really matter. It's all very similar. Do you notice how there's no x term? Like, we just see an x squared, but there is no x term. Okay, so this means that I can solve directly for x. I can move all the other numbers over to the other side, so we subtract 11. So we get 2x squared is equal to 48. I divide by 2, I get x squared is 24. And then I square root 24. And we say plus or minus the square root of 24. Okay, plus or minus the square root of 24. But now I have to reduce down the square root of 24. Okay? We know that x is equal to this. So I don't care how you work with it. I know a lot of you like to do this whole factor tree method to break it down. That's completely fine. I would probably go with the biggest perfect square factor, but let me just show you what I mean by factor tree again. That's the 2 times 12, 2 times 6, 2 times 3, and you just buddy up, right? So a 2 comes out. Oh, forgot my plus or minus there. A 2 comes out, and then the 2 and the 3 stay in to make a 6. So this is plus or minus 2 radical 6. How I would have done it, I would have thought about 24 as well. I could divide it out. I could divide out 4. And nothing higher, no other bigger perfect square. Like the next biggest perfect square past 4 is 9. And I can't take 24 divided by 9 or 24 divided by 16. And obviously none of those work. So the biggest perfect square factor I can factor out is 4. Divide it out, 6. And then take it out of the square root. The square root of 4 is 2. Okay. Okay, this one's the same thing. We've got the square root, or sorry, x minus 5 squared is equal to 9. Now, instead of like foiling this, instead of actually take x minus 5 times x minus 5, what I want to do is just simply take the square root right away. Okay? If I just simply take the square root right away, I can simplify things. Because doesn't square rooting take away the squared? So therefore, what I can do here is just say x minus 5 is equal to plus or minus 3. Okay, well, when you've got it equal to a plus or minus, that's really telling you two different things. That's really making two equations for you. It's really saying x minus 5 is equal to positive 3, or x minus 5 is equal to negative 3. Okay, plus or minus 3 means I could have both the positive or the negative version, 3. All right, well, I add the 5 over to the other side, we get x is equal to 8. I add the 5 over to the other side, I get x is equal to 2. Two different solutions. Okay. Now, I think we would all agree that, man, look, on this left side, if we could get this down to something where it's a binomial, two terms, a binomial squared and just a constant, just a number on the other side, solving it is actually pretty easy. If I can get this down to a two-term squared is equal to a number, I square root the other side. I'll have to do this whole plus or minus thing where I get two solutions, but honestly, that's not too bad. So take a look here. Take a look here. I see this whole b term. I see a b term here. So I need to do something with this that's not, I can't just solve directly. So maybe there's some other route that I can take. What do you notice about the left side? What do you notice about the left side of this equation? Don't try to bring the 28 over yet. What do you notice about this? Luke? Good. And what are the factors that it goes into? 6 and 6. And what's our my middle term? 12 So the factors of 36 are 6 and 6. Right? And 6 plus 6 is 12. That is what's called a perfect square trinomial. Okay? When this factors into the same number, don't write this, but we could write x plus 6, x plus 6. Well, what's another way to write that? X plus 6 squared. And now this problem becomes a lot like what we did up in the last one. Okay? And the reason we were able to do that is because this left side was what's called a perfect square trinomial. The last number was a perfect square. And then when I factored that number, when I found the factors of that number, when I square rooted that number, those two factors added together to get my middle term. All right, so now we square root the opposite side. Unfortunately for this one, 28 is not a perfect square. So I got to kind of leave it like that, or let's try to reduce that down. Let's take 28. Let's factor that down. That's 2 and 14 and 2 and 7. So that's 2 radical 7. X plus 6 is equal to plus or minus 2 radical 7 because that's 4 times 7. And now the only other thing left to do, honestly, 2 radical 7 is just a decimal, right? So if I wanted to find a value, I could. I'll just plug it in my calculator. 2 radical 7 turns out to be, well, it's probably like 5.3 or something like that. It's just a little bit above 25, and 28 was. So it's just a decimal. So please understand that I could just get a number here if I wanted to. But to keep it exact, I'll subtract over the 6 to the other side, here to here. I'm going to say negative 6 plus or minus 2 radical 7, and that's my answer. Okay? Anything beyond that, and I will have to estimate the value. Anything beyond that, I will have to round the decimal. Anything beyond that, and I'll have to go to my calculator to plug it in to see what it actually comes out to be. Okay? Okay, questions about that? So, maybe, look, if we could get a perfect square trinomial on the left side that's equal to a number, it'll flow right into this whole just square rooting the other side and solving the two equations. So man, I guess what we're looking for is to try to get a perfect square trinomial on the left side. Okay, that is what's called completing the square. Okay, the methods in the previous examples can be used only for expressions that are perfect squares. However, you can actually force that to happen. Okay, you can force that to happen. You can make that perfect square happen. Okay, and that's called completing the square. If a quadratic expression of the form x squared plus bx cannot model a perfect square, you can add this term to form perfect square trinomial. This is called completing the square. I think this is on the top of the back page, right? Yeah. So this is completing the square. Notice that I only have two terms here, x squared plus bx. Okay, something has happened to the constant. It's gone. I'll show you what I mean there in a little bit. But something has already happened to the constant. Okay? So to complete the square with just x squared plus bx, to force it into one of those perfect square trinomials, what you do is you add half of b squared. You add half of b and you square it. Okay? You add half of b and you square it. So for example, to complete the square here, to force x squared plus 6x into being a perfect square trinomial, the number that goes in the box is 9. Because half of 6 is 3. 3 squared is 9. And how does that help us? Well, it will force it into being a perfect square trinomial. It'll force it into that x plus 3 quantity squared that we'd like it to be in. Okay? Now, what are these values? Just arbitrarily, like if I don't just have numbers on them. Okay, well, this is always going to be b over 2 squared, right? That's what we're going to add to the end there, b over 2 squared. Now, the cool part about this is that this number inside that parenthesis in the end is always going to be b over 2. It's always going to be b over 2. That will never change, okay? So let's try some. Okay. X squared minus 14x. What fills in my blank? What completes the square here? What fills in that gray box? Well, what's my b value? 14, right? I should say negative 14. My b value is negative 14. What's half of 14? 7. Square that, and 49 fills in my blank. Why does 49 fill in my blank? Now take a look. What's the square root of 49? 7 and 7, right? What's negative 7 plus negative 7? Negative 14. It forces it into being factorable. I didn't even need to check that though, because completing the square ensures that that will always happen. Okay? That this will always turn into b over 2. Negative 14 over 2 is negative 7. That will always happen if we add 49 to the end. Take a look at this one. Now, this is a little tricky because b is odd. What would happen if I tried to take 9 over 2? I get 4.5, right? So let's keep it as fraction form. Okay, so what fills in my blank? Well, 9 over 2 squared. Let's not take it out of fraction form. 9 over 2 squared is 81 fourths. 81 fourths. What does that mean in terms of what it factors down into? Because right now, like I'm thinking, there's no way I'm going to try to find the factors of 81 fourths that will actually get me 9. But I don't need to. I don't need to because I know this is going to turn into x plus b over 2 squared. And that will always happen. Okay, let's take a look at this next one. Another odd one. X squared plus 3x plus something. Okay, so what fills in my blank? Somebody tell me. What fills in my blank here? What do you think? Yeah, you got it.
Is it 9 fourths?
9 fourths, good. 9 fourths fills in that blank. How do I know that? Well, 3 over 2 squared is 9 fourths. I square the top, square the bottom, 9 fourths. So what does that turn into then? Well, x plus 3 over 2 squared. Now, why am I going through the process of figuring out what goes in the gray box if I know what it's going to factor into in the end anyway? Like, it seems silly. Why are we going through the motions and finding out what goes in the gray box if I already know what it's going to factor into? Well, because the process of solving the equation requires me to know this number. Here, I guess I should just show you. Now, these are the steps for completing the square. Okay, these are the steps for completing the square. First step, collect the variable terms to one side and the constants to the other. Remember how I said something happens to our C value, but we don't know where it went yet? Well, this is what happened to it. We moved the constant to the other side. Okay, we moved this constant over to the other side so that we just had x squared plus bx on the left side and then c on the other. Now, this is actually going to be extremely important tomorrow, this second step. As needed, divide everything through by a. You cannot complete the square if there's an a term sitting out front. You cannot complete the square if it's like 2x squared. Like, look at all of the ones that we've done so far. Like on at least on the back here, none of them have had a number out front. And none of them will have a number out front on the bottom either. Okay? We'll talk about that tomorrow. Because you can't complete the square if there is a number out front. If it's like a 2x squared, you can't complete the square. You got to do something to it. What do you do? Well, you divide through by whatever's in front. Everybody gets divided through by that value. Third step, Complete the square by adding b over 2 squared to both sides, because whatever we do to one side, we got to do to the other, right? So what goes in the box is extremely important now because it gets added to both sides. Added to both sides. We factor the variable expression as a perfect square. We complete the square, get it down to its binomial, take the square root of both sides, and solve for the values of the variable. Let me show you here. Okay, let's do this one together here. X squared is equal to 12x minus 1. Okay, we get variable terms to one side and we get the constants to the other. So I need to get this 12x over to the left side, correct? So I say x squared minus 12x. I'm going to leave a little room, and you'll see here in a second why. All right, now at this point, I need to complete the square. So let me ask you this question. What fills in my blank on both sides? What fills in my blank? Well, what's half of 12? Squared? 36 gets added to both sides. 36 gets added to both sides. That's the number in the gray box. Right? That's why we were spending so much time looking at that, looking for that number, because I have to add it to both sides. Well, that means on the left side, this factors, right? It factors into x minus 6 squared. You know, I can see it here because 36, the factors of 36, it had to get to negative 12 or negative 6, negative 6. But I didn't need to know that because it turned into b over 2. b was negative 12 divided by 2 is negative 6. So I know that it's going to factor into an x minus 6 if I add 36 to both sides. I'm kind of forcing that perfect square to happen. All right, now negative 20 plus 36 is 16 on the right side. And now this becomes like a problem that we had on the front, where we have an x minus, we have 2 terms squared on the left side. And now look on the right side, that's a perfect square. So life is really good at this point. I square root the opposite side, I get x minus 6 is equal to plus or minus 4. And now I have 2 equations. I've got x minus 6 is 4. I've got x minus 6 is negative 4, so I add the 6's. X is 10 or 2. Now, you know what it tells me about this problem? If these come out to be whole numbers, that tells me that this was originally factorable. Okay? If those come out to be whole numbers, that was originally factorable. Let's try this one. Make sure this is the same one for you guys. Minus 27 equal to 4x. Perfect. All right. So first step, variables to the left, constants to the right. Subtract the 4x to the left side. Leave a little room. Add the 27 to the right side. Okay, what fills in my blank? What fills in my blank? Somebody tell me. What fills in my blank? 4. 4 fills in my blank. And I can see that because I take half of negative 4, which is negative 2. I square it, I get positive 4. So I add 4 to both sides. Now, in this case, this makes that factor into x minus 2 squared is equal to 31. Right? I knew that that was going to turn into b over 2. I can see it right there because the factors of 4 that had to get to negative 4, negative 2, negative 2. But I didn't need to know that. It's always going to turn into b over 2. Negative 4 over 2 is negative 2. So now I square root the opposite side. Now this one is not a perfect square. I get x minus 2 is equal to plus or minus the square root of 31. Can I even reduce down the square root of 31? No. 31 is prime. I can't do anything to it. It stays there as it is. So the last thing that I need to do is just get x completely alone by adding the 2 over to the other side. So I can literally leave it x is equal to 2 plus or minus the square root of 31. Because if I wanted to evaluate the square root of 31, it would be, I don't know, 5.6 or something like that. So it's not something that I can write exactly as a decimal. Okay, that's the most exact I can get. All right, last one here. Okay. This one's going to be a little bit difficult. I can tell right away because when I go to put the variables on the left side and the constants to the right, my b term is odd. When your b term is odd, life's a little bit more difficult. You're going to have to work with some fractions, right? Think, look above at part B there above. Do we see how we had a 9 up there? What did we add to both sides? 81 fourths. Right, we added 81 fourths to both sides. How do I get that? Well, that's 9 over 2 squared, right? That's 9 over 2 squared. 81 over 4. Okay? Now, here's where life gets a little bit, difficult. This is going to be 9 over 2, right? I don't need to try to factor anything down there. I know that that's going to factor into b over 2. But on the right side, I've got to work with some fractions. 2 plus 81 fourths, right? Okay, well, to get common denominators, I need to turn 2 into fourths, right? So isn't 2 8 fourths? So add the numerators together, 89 fourths. Okay, now I square root the right side. I square root the right side. I get x minus 9 over 2 is equal to plus or minus the square root of 89 over 4. But we learned back in chapter 1 that if I've got a fraction, I can separate that square root into both the numerator and the denominator of that fraction. So we can say x minus 9 halves is equal to plus or minus the square root of 89 over the square root of 4, which is just 2. And now I add the 9 halves over to the other side. I get x completely alone. So x is equal to 9 over 2 plus or minus the square root of 89 over 2. And now, because I already have common denominators, 9 plus or minus the square root of 89 all over 2. And that's my answer. Which, that answer actually looks a lot like something I would get if I were to try to use the quadratic formula, which is something that we'll talk about in section 5-6, I believe. Okay? You know how this answer is really messy and weird? The reason, this basically tells me that this is not factorable, right? This part C and actually part B here that we had seen, the last one, because it came out to be the square root of 31, it tells me my original is not factorable. It doesn't tell me that it doesn't have x-intercepts. It still has x-intercepts. Like if I actually wanted to figure out where this would actually cross the x-axis, if I wanted to, sure, let's take 9 plus the square root of 89 over 2, and then 9 minus the square root of 89 over 2. 9 plus the square root of 89 divided by 2. So it's got an x-intercept at 9.22, and then 9 minus the square root of 89 divided by 2. So 9.22 and negative 0.22. Okay. Notice that the decimals are the same because they're equidistant from my axis of symmetry. Okay. All right, so that's how we complete the square. Completing the square again is when if something is not factorable. This is one of the things that we have in our mathematical toolbox to use. All right, so long, everybody following along at home, and we'll see you when we see you.